Hello and welcome to the next video of our channel Practical Hope. In this video we are going to do numerical integration by Trapezoidal and Simpson's rule. First, what is numerical integration? It is the process of computing the value of a definite integral, integration a to b fx dx, from a set of numerical values of the integrand fx. We need numerical integration because sometimes solutions are too complicated. Certain functions do not possess closed form solutions, and sometimes the form of the function is not known. We are going to replace the function to be integrated by a polynomial px, assuming that integration of fx dx is equal to integration of px dx. This polynomial px can be of the order 1 or order 2 or order 3. Say this is the function fx and these are the limits x equal to a to x equal to b. Now if we want to integrate this function from a to b, then it is equivalent to area under this curve. Next, how to calculate area under the curve? Now we have with us these data points x and y. We are going to consider a number of strips and those strips will cover the whole area. Say we consider this one strip. Suppose if we connect two consecutive points by a straight line like this. The strip is like a trapezium. Say this width of the strip is h and can be calculated using this. Now total area under the curve can be evaluated like this. The sum of all the trapeziums that will cover the whole area under the curve. If we rearrange the terms, we get this expression. This is the trapezoidal formula because this strip is like a trapezium. Next, there can be another case in which instead of connecting the 2 points via a straight line, we can connect 3 points via parabola like this. So we are considering this polynomial px of the order 2, quadratic. So we have connected 3 points yk plus 1 and yk plus 2 like this. Now if we calculate area under the curve using these strips, then we get an expression like this. If we rearrange the terms, we get this. This is the Simpson's 1 by 3 formula. You can see from this expression that it's better if we have odd number of terms, 3 or 5, 7, 9 and so on. And finally, if we consider a cubic polynomial, then we get strips like these, and if we calculate area, then we get an expression like this. By rearranging the terms, we get this expression. This is the Simpson's 3 by 8 formula because there is a multiplication factor of 3 by 8. In the previous formula of Simpson's 1 by 3, this multiplication factor was 1 by 3. So we have got all the three expressions: trapezoidal formula, Simpson's 1 by 3 formula and Simpson's 3 by 8 formula. Let's switch over to the programming. This is the sign notes window. First, give a suitable title. Evaluate integral using trapezoidal rule. CLC is to clear the console. Clear will clear the variables of the workspace. These are the x points that we are considering, and these are the corresponding y values. This is the trapezoidal formula. Here, first we have calculated the length of x, that is the number of elements of x. Here we are having 11 terms. Next we have calculated h, that is step size, and it is x2 minus x1. x2 is 0.1 and x1 is 0. Then we have calculated this I equal to y1 plus yn, because from the expression you can see y1 is not multiplied by any factor, just like y2, y3, y4, and so is the case with yn. So we are adding y1 and yn initially to I, and then these y2, y3, y4 we will add later via a loop. Next we consider a for loop that will run from 2 to n minus 1 in steps of 1. Now we can write the expression I equal to I plus 2 multiplied by yi. For I equal to 2, it will add y2. For I equal to 3, it will add y3, and it will add till I equal to n minus 1. So y n minus 1. all these terms will be multiplied by 2 and will be added to I. So we get the value of the final integral I. Now we need to multiply by this factor of h by 2. Now we can display the value of the integral using trapezoidal rule is I. Minimize this. Let's execute it. Save it. Integration trapezoidal. Go to the console. So the value of the integral using trapezoidal rule is 2. CLC. Next, consider Simpson's 1 by 3 formula. Give the suitable title. Evaluate integral using Simpson's 1 by 3 rule. Method 1. CLC and clear. These are the x values. Then these are the y values. And this is the expression for Simpson's 1 by 3 formula. First, we calculate number of elements of x or y. Then we calculate the step size h equal to x2 minus x1. And as discussed in the previous program, I is equal to y1 plus yn. For terms y2 till yn minus 1, we'll use a for loop. Now here we can use two loops. One for I equal to 2 to n minus 1 with steps of 2. This loop will take care of terms y2, y4, y6 and so on. So I equal to I plus 4 multiplied by yi. For odd terms we can write another for loop for I equal to 3 to n minus 1 in steps of 2. The expression will be I is equals to I plus 2 yi. This expression will take care of the odd terms. Finally, we need to multiply this I by this factor h by 3. So I equal to h by 3 multiplied by I. Now we have got the value of the integral. We just need to display it. DISP, the value of the integral using Simpson 1 by 3 rule is I. Minimize it. Execute it. Save it. Integration Simpson 1 by 3 method 1. Go to the console. So you can see we are getting the result. We can evaluate the integral using Simpson's 1 by 3 formula by another method. Now instead of using two loops, we can use one loop, right? And within that for loop, we can write a condition. If the term is even, then we'll multiply the term by 4, and if the term is odd, then we'll multiply the term by 2. For I equal to 2 to n minus 1, now we are taking the step size of 1 because we are considering all the terms in a single loop. So if modulo I comma 2 equal to 0, then I equal to I plus 4yi, else I equal to I plus 2yi. What modulo I comma 2 will do is, if I is 2, initial value of I is 2, so 2 divided by 2, it is exactly divisible, so remainder will be 0. Now if the remainder is 0, then it will consider this term yi. Now since I is 2, so it will add 4 times y2. For next loop I equal to 3, so modulo 3 comma 2. Now 3 is not exactly divisible by 2, so remainder cannot be 0, so it will take this second expression I equal to I plus 2y3, so it will add this term y3. In this way it will add up the even terms and odd terms in the consecutive loops. Once we have this value of I, we can multiply it by h by 3, and finally we can display the value of the integral using Simpson 1 by 3 rule is this. Minimize it, execute it, save it, go to the console. So this is the final result. Finally, we can write the program in another way, and this method is shortest. But there's one thing that you need to take care of. Say y1 comma n equal to 0. we are setting the last element or last y term as 0. Why we are setting it to 0 we'll discuss later. Next we set a for loop from 2 to n minus 1 with steps of 2. Now we write this expression I equal to I plus 4yi plus 2 yi plus 1. You can see from this expression, instead of taking one term at a time, we are taking two terms simultaneously. So now if you put I equal to 2, then it will add y2 plus y3. It will take care of two terms simultaneously. Now next I should not be 3, it should be 4. That's why we have taken this step of 2. So it will take values y4 plus y5. So it will take values 4 times y4 plus 2 times y5. And it is same as you can see from this expression. So in this way we can add both odd and even terms simultaneously. But say I reaches this n minus 1. So y n minus 1. This term will be yn, but yn we don't need to add because we have already added this yn term initially to I. So in order to avoid this additional addition of yn, we have set last element of y as 0 here. That's why this expression y1 comma n is equal to 0 is there. So there will be no error in the final answer. Then I equal to h by 3 multiplied by I, and finally display the value of the integral is I. Let's minimize it, execute it, save it, go to the console. This is the final result. Next is Simpson's 3/8 formula. First give a suitable title. Then these are the x values and y values. Then we need to calculate n, h, and we need to set the initial value of I. This is the expression for Simpson's 3/8 formula. Now one simple way is we can set 3 loops. One for y2, y5 and so on. Then second for y3, y6 and so on. And third loop for y4, y7 and so on. First for loop I, that will vary from 2 to n minus 1 in steps of 3, and I equal to I plus 3yi. So here we are considering the terms y2, y5 and so on. Next for equal to I from 3 to n minus 1 with steps of 3, I equal to I plus 3yi. This loop will start from 3, so it will incorporate y3, y6 and so on. And finally third loop that will run from 4 to n minus 1 with steps of 3. So these are the 3 loops and will take care of this whole expression. So we have got the final value of I. We can multiply it by 3/8 and then we can display. Minimize it, execute it, save it, go to the console. This is the final result. Finally we can write this Simpson's 3/8 formula program using the method as we did for Simpson's 1/3 formula. This method will be the simplest. These are the x and y values and these are n, h and initial value of I. Set y1 comma n colon n plus 1 equal to 0. Why this we are setting to 0 we'll discuss later. Next for loop that will run from 2 to n minus 1. I equal to 3 times yi plus 3 times yi plus 1 plus 2 times yi plus 2. Logic is same as we discussed while writing the shortest program for Simpson's 1/3 rule. As you can see from the Simpson's 3/8 formula, there are 3 terms. 3 times y2 plus 3 times y3 plus 2 times y4, and this is the pattern that will follow. We are taking 3 terms at a time, yi plus 1 and yi plus 2, 3 consecutive terms at a time. So there is no need for additional loops. Using just a single for loop we'll get the value of the final integral. But here also we need to take care of one important thing. Suppose I is n minus 1, the final value of I. So this term will be yn minus 1, that is okay. Next term is yn, and then the final term will be yn plus 1. So yn and yn plus 1, these two terms, we don't want these two terms in this final value of I. So that's why we have written this statement y1 comma n colon n plus 1 equal to 0. It will set both n and n plus 1 term as 0. So there will be no error in the final answer. Now we can multiply I by 3h by 8, and finally we can display the value of the integral is this. Minimize, execute it, save it, go to the console. This is the final result. Now instead of writing three separate programs for trapezoidal Simpsons 1/3 and Simpsons 3/8 formula, we can write one program, single program, that will take care of all the three methods discussed earlier. Give a suitable title. These are the x and y values. Here also we'll first calculate n, then h, and then we'll set the initial value of I. And this also we discussed earlier, why this y1 comma n colon n plus 1 is 0. First we are setting an input variable m equal to input, enter 1 for trapezoidal, 2 for Simpson 1/3 and 3 for Simpson 3/8. When we are going to execute this whole program, it will ask which method we want to implement. So then we'll need to press 1 for trapezoidal, 2 for Simpson 1/3 and 3 for Simpson 3/8 formula. We are going to use a for loop that will run from 2 to n minus 1 in steps of m. Because if it's trapezoidal, then we have to take every term separately, y2, y3, y4 and so on. And for Simpson 1/3, we are going to take two terms simultaneously, y2 and y3 in a single expression. And similarly for Simpsons 3/8, we are going to take three terms simultaneously, yi plus 1 and yi plus 2. If m is 1, then this is the trapezoidal formula. I should be I plus 2 yi. And see, we are setting this constant multiplier 1/2. So this 1/2 is 0.5 and it's for trapezoidal. Else if m equal to 2, this is the Simpsons 1/3 formula, I equal to I plus 4 yi plus 2 yi plus 1. So we are considering two terms simultaneously. C equal to 1/3, this multiplication factor. And finally, else if m equal to 3, then I equal to 3yi plus 3yi plus 1 plus 2yi plus 2. So if we are going to implement trapezoidal, then it will take term by term. If we are taking Simpsons 1/3, then it will take two terms. And if we are using Simpsons 3/8, it will take three terms simultaneously. Finally, we compute the final value of I. Once we got the value of I, we can display it. The value of the integral is this. Minimize it, execute it, save it. Now it is asking for the method 1 for trapezoidal, 2 for Simpson 1/3 and 3 for Simpson 3/8. Let's type 1. So this is via trapezoidal. Execute again. Type 2. This is via Simpson 1/3. And finally execute again. Type 3. So this is via Simpson's 3/8 rule. We have discussed all the three numerical integration techniques. I hope you like this video. Share it with your friends and don't forget to subscribe our channel if you haven't done it yet.